Hey, welcome. Today in IED we're going to be learning about holes, and more holes. How to drill holes. Okay, hole definitions through. A lot of times you're going to see this as THRU. For example, up here THRU. Here's another one THRU. Hole cuts through entire thickness. All right. Clearance. Hole large enough to allow screw head and driver to pass through. Blind, hole does not cut through entire thickness. So examples of blinds. Here, let's go through. Here's two or other through. If you look at the front, this is a section view here now. They've cut away part of it from the lines you can see here. They've done a section view, and here's the section lines. These are here are through holes. All right, they're cut all the way through. The blind here would be an example of a blind. Here would be an example of a blind. It does not cut through the entire thickness. All right. Okay, now this is the same one, all right, same drawing, and what they've done is they've added to it. So what we want to point out here then is a countersink. It's a conical shaped recess around the hole at the surface. So a countersink, for example, all right, a countersink would be right here. Is what they're giving us an example of. Notice what it looks like in our section view here. This right here is our countersink. There we go. Counterbore. It's a cylindrical recess around hole at surface. Let's go back to the countersink. It's often used to accept a tapered screw. All right, so that it would be flat across the top here. You notice that a screw would fit in there. Counterbore, so cylindrical recess around hole at surface. Here is a good example of a counterbore. Here is another good example of a counterbore. Around hole at the surface, often used to receive a bolt head or nut. It's going to allow that bolt head, the whole thing, you'd stick the driver on so that the whole thing would fit in there. Again, it's so that it would be flat across the top, so that these two surfaces, all right, so that they wouldn't stick out. All right. Tapered, hole as internal threads. All right, tapped. I'll get it right yet. Tapped, hole has internal threads. This one right here is tapped. They have these internal threads. Okay, let's go over this a little bit. We've discussed this a little bit here in class. Um, Things that we have to give. First of all, for a hole that you're drilled, you're going to give the diameter. In this specific example over here, all right, they're telling us that the diameter, that's that diameter symbol right there, is 0.25. This right here stands for the depth. This is how deep the hole goes down, 0.75 inches. It has a counterbore. The counterbore has a diameter of 0.38 and the counterbore's depth is 0.25. All right, that's what they're telling us at this. All right. A 0.38 inch diameter blind hole is drilled 0.5 inches deep. So what we have here is they're telling us the diameter is 0.38, the depth is 0.5. It's a blind hole, meaning you can't see through it. That's what blind means. All right. So they're telling us the depth here. Okay, a 0.38 diameter hole is drilled completely through. All right, this hole here has a diameter of 0.38. Through means it goes all the way through the material. Okay, on this one right here, all right, this is the countersink symbol. All right, what this is telling us is that the hole has a diameter of 0.5 and it goes all the way through. There is a 1-inch countersink. That's what the countersink has a diameter of 1 inch, and they're also telling us the degrees. All right, thread notes. All right, threads are dimensioned with the use of local notes. Two methods, ISO or Unified National Thread Method. Up here, all right, they're telling us that it's 5/16 18 UNC. All right, 5/16 18 UNC. Let's talk about what this UNC means here. 5/16, this gives us the major diameter. It's a diameter of 5/16. All right, that's the largest diameter. Threads per inch, all right, is 18. All right, this number here tells us the number of threads per inch. UNC means coarse or fine threads. In this case, C for coarse, F would be for fine. Different ways, different types of threading we have. Okay, on here then. 12. This is for the metric system. M is for the metric. All right, 12, the nominal diameter, telling it's a 12. All right, 12 millimeters, I believe, is what that stands for. 1.5. This gives us the pitch of the threads, 1.5. All right. 6H. All right. The 6, the grade of tolerance in the threads, can be a whole number from 3 to 9. This is telling us, again, the grade of tolerance in the threads can be a whole number from 3 to 9. H, allowance. H means no allowance. G means tight allowance. So this means there'd be no allowance. We're going to go over allowances later this week. And then through tells us prior to through may appear on LH or for left-hand threading. In this case, they're telling us it's going all the way through. So when we get done with these notes, we're going to do a short little lesson on Inventor, and from there, then we'll get you going on your doing some threads today, or doing some drilling some holes today. Catch you on the flip side.